Good morning, everyone. I hope you all are well. I am here for the lecture on kind of function of class 12th. As we studied about the function in class 11th also, function 1. There we discussed about the different type of functions and their domain and range. It means algebraic functions, trigonometric functions, exponential functions, logarithmic functions, and some special functions like modulus functions, greatest integer functions, least integer functions, and fractional part functions, and their graphs also. So I have to request all of you that revise the contents of the class 11 one more time at your home, because this topic function is connected with the function 1 of class 11th. It means here in class 12 this is function 2nd. So let's start with the kind of function. It is the first lecture and I have to take the 2 lecture on this. So first slide, just see onto the screen. Kind of functions. Here in mathematics there are 4 kind of functions. First, 1 1 onto, it is also known as the bijective function. Second, 1 1 into. Third, many 1 onto. Fourth, many 1 into functions. Here 1 1 and many 1 are the criterias depending onto the domain, and onto and into are the criterias depending onto the codomains. So we have to just segregate 1 1 and many 1 from onto and into. So first of all I am going to just talk about 1 1 and many 1 function, and there are 3 methods to recognize whether the function is 1 1 or many 1. First, by mapping. Second, by graph. Third, by analysis. Here the mathematical analysis is the important, because when the mathematical expression is given, then you have to just apply this method to recognize whether the function is 1 1 or many 1. Okay. Now I am going to talk about 1 1 and many 1 by mapping. When we are talking about 1 1 function by mapping, then as you know very well that in this condition function is defined from a set A to set B, and if each element of codomain set have the unique pre-image in domain set, it means each element of domain set have the different image in codomain set B, then we can say that the given function is 1 1 function. Let's see example. A function f defined from set A to set B, where a equals to a comma b comma c comma d and b equals to 1 comma 2 comma 3 comma 4 as given as below. A have the image on 3, b have the image on 1, c have the image on 2, d have the image on 4. From the mapping it is clear that there are no any pre-images of codomain elements more than 1. So that's why this mapping representing a 1 1 function. It means injective functions. So get all of you have to write onto your notebook. Now 1 1 function by graph. When we are talking about there is a graph of any function is given, then whether the graph representing 1 1 function or not, we have to draw a line parallel to x-axis, and if that line cut the graph at single point, then we say that the given graph representing a 1 1 function, otherwise not. Just see the graph onto the screen. It is clear that here the line parallel to x-axis cut the graph at only one point, so that's why this function is 1 1. Now next, many 1 function by mapping. Going to talk about, when we are talking about the many 1 function by mapping, it means a function defined from set A to set B, and if more than one element of A have the single image in B, it means many is going to 1, then we say that the function defined from set A to set B is a many 1 function. Let's see example mentioned onto your screen. In the mapping it is clear that A have the image on 1, B have the image on 2, and also C have the image on 2. It means there are two element of domain set have the single image in codomain set. It means many is going to 1, so that's why this function is many 1. It's okay all of you. Now it is very important that you have to just know about the 1 and many 1 function always be depends onto the domain. If domain of the given function is changes, then it may be possible that a many 1 function going to be converted into the 1 function. So you have to just see what is the given domain of the function, and after that you have to conclude whether it is 1 or many 1. It's okay all of you. Okay, now next, many 1 function by graph. When we talking about many 1 function by graph, it means a graph is given, then we have to draw a line parallel to x-axis. If the line parallel to x-axis cut the graph more than one point, then graph must be represent a many 1 function. It's okay all of you. Good. Now just write it. Now we are going to talk about the third method to recognize 1 and many 1 function, which is analytical method. It means 1 and many 1 function by analysis. And here to check whether the function is 1 or many 1, we have to just use the following step. Step 1, we have to take any two value of x from the domain of the given function. Let it is x and y. Now we have to find fx already given and fy by putting at the place of x equals to y, and put fx equals to fy and simplify it. After simplifying it, if we get for every y x have only one value, then the given function is 1, and if for every y x have more than one value, then function is many 1. So good all of you, you have to just write the steps onto your copy. Good. Now there is an example. You have to just see example number 1. Your function f defined from real number to real number given by fx equals to 5x plus 1. Then prove that it is 1. So here the domain of the function is real number. Okay everyone. Now we have to suppose any two value of x belongs from real number. Let they are x and y. Fx is given, which is 5x plus 1. Now find fy, which is 5y plus 1. Now we have to put fx equals to fy. After putting fx equals to fy, we get 5x plus 1 equals to 5y plus 1. Now from both sides 1 is going to be cancelled, so we left with 5x plus 5y. And one more thing you have to write onto your class notes. Here is simplification of fx equals to fy, only numerical value is going to be cancelled, but if a factor is common on both sides, then don't cancel that factor. So get all of you, be careful. Now from the given condition, it is clear that this function is 1. Let's see a more example. Example 2. Prove that in R, it means real number, function fx equals to 2x square plus 1 is a many 1 function. Let any two value of x, as we know, x and y. After that fx is already given 2x square plus 1, and we have to find fy, which is 2y square plus 1. Now we have to put fx equals to fy. After putting, we get 2x square plus 1 equals to 2y square plus 1. Now 1 is going to cancel, so we left with x square equals to y square. After shifting y square on left side, we get x square minus y square equals to 0. We have to apply square difference formula, so we get x minus y into x plus y equals to 0. So we can say that x equals to y and x equals to minus y. Now here condition is given, we have to just talk about in real number. In domain is real number, so that's why here the both solution is countable. So from here it is clear that for every y we get the two values of x. Now one is y, another one is minus y. It means if we let y equals to 1 from the real number, then x equals to 1 and also x equals to minus 1. So for 1 by x have two value, so that's why this is many 1 function. So get all of you, so write down. Now there are homework in which there are 3 questions, you have to solve it. you have to write onto your copy, everyone. Good. Now next, everyone prepare your notebook at your home. Be safe, enjoy learning from your home. Don't move outside from your home. Keep watching videos regularly, everyone, and thank you so much.